In this video, we're going to take a look at zeros and x-intercepts of functions. Now, we've talked about these two topics before in different sections. We've gone over what it means for a point to be an x-intercept. We've talked about how we find x-intercepts for certain types of equations or functions, and we've also looked at finding zeros of functions. So let's talk about this again. They are connected to each other. Okay, in fact, the way you find a zero and an x-intercept is exactly the same. The situation you're in is a little different sometimes. Zeros come from actual named functions, and x-intercepts can come from any relation that you happen to have. What they have in common is how you find them. What we do in either case is we set the equation that we have equal to 0 and we solve for x. This is also known as plugging 0 in for y or f of x. That terminology is used mainly with finding the x-intercepts, whereas setting the equation equal to 0 and solving is used mainly when we're talking about how we find the zeros of a certain polynomial, or for that matter, any other function. But they're actually the same thing. You are plugging a 0 in on the side where y or f of x is, and then you're solving for that x value. So what I want you to think about is that 0 and x-intercepts are really coming from the same place, okay? They are where the equation, the function, is zeroed out, where it is on the x-axis. Positive zeros are x-intercepts. We use them for the x-coordinates of the x-intercepts. I say positive zeros. Real zeros are the x-intercepts. Imaginary zeros are not x-intercepts because we can't graph imaginary numbers in the rectangular coordinate system that we use, okay? So we know that only real zeros can be x-intercepts, okay? Imaginary zeros cannot be x-intercepts. Now, we've seen how to solve several different types of equations up to this point. We're working on polynomial equations right now in this particular chapter. So we can illustrate this with some quadratics. We can look at it from some cubics. We could also look at it from some higher degree polynomials that have already been factored for us, since we haven't made it to the section where we find out how to solve just your random polynomial for a particular zero. So let's look at an example, maybe a couple of different ones, where we are finding the zeros and then how they are x-intercepts, how we can tell if they're x-intercepts or not. Okay, let's consider this function here. We're going to find the zeros for this polynomial function. This function has already been factored. This is called factored form. That's when you take a polynomial, factor it into the product of binomial factors, trinomial factors if you have to, but in most cases the ones we work with are in binomial factors. And then you just write it like that, okay? And sometimes the different binomial factors have exponents and sometimes they don't. And I'm just noticing a little goof up on my part here. That was not supposed to have been a 3, and I don't know if I can fix that or not. It won't let me erase it. So let's do this, and we'll just go with the others that we have, okay? We'll just, we'll pretend that f of x is just x plus 3 times x minus 2 squared. I had repeated that x plus 3 again and didn't intend to. All right, so what we do is we set the f of x part equal to 0, which you already know if you have a polynomial that's been factored. To solve, you set each individual factor equal to 0, so I'm going to have an x plus 3 equals 0. And then x minus 2, the square that's on the x minus 2 just simply means that there are two x minus 2 factors there. I don't have to set them both equal to 0 because one of them will give me the answer that comes from that one, okay? So I will get two solutions here, a negative 3 from the first factor and then a 2 from the second, okay? So those are my two zeros. Let's do this, 0 and x-intercept. Put those next to each other in a little table. I've got two zeros, one at negative 3, one at 2. So my x-intercept would be negative 3, 0, because remember, when you're writing that ordered pair, the 0 is what you plugged in for y. So that's your y-coordinate. And then what you found is your x-coordinate. Same thing here, 2 0 will be that x-intercept. Now we did see that that particular one came from a binomial that was squared. We're going to talk about what that square has to do with the graph in probably the next video. Let's take a look at another one. All right, here is another example. We want to find the zeros and x-intercepts of this function. X cubed minus 2x squared plus 2x minus 4. This time it's not already factored, so I'm going to go through the process of factoring it. We'll go ahead and set the f of x equal to 0. We have a 4-term polynomial. We can try to factor it by grouping, which means we'll take the first 2 terms together and then the last 2 together. And we take out a common factor from each group. X squared is common from the first 2. And then a 2 would be common from the second 2. We do get a common binomial when we do that. So I'll factor that out next. And then that leaves me with the x squared plus 2. So I've got one linear binomial factor and then one quadratic. We'll go ahead and set each one of those equal to 0. If you run into one like this and you can factor a second time, go ahead and do that if you want to. But once you get down to the binomials, you can set equal to 0 and solve. For the linear, we get a 2. And then for the quadratic, we're going to have to use the square root property. I believe we're going to wind up having an imaginary number there. When I move the 2 over, it becomes negative. Square root of both sides gives me x is equal to plus or minus the square root of negative 2. And the square root of negative 2 simplifies to I on the square root of 2. So I've got 3 answers, which makes sense. This is a 3rd degree polynomial. We should have 3 zeros. 2 of them are imaginary. These 2 will not make x-intercepts, but this one will. So let's write down what we've found. My first 0 is a 2. My second would be a positive I on the square root of 2. And my third would be a negative I on the square root of 2. For the 0 that's at 2, my x-intercept is 2, 0. And then for the other 2, we don't have an x-intercept. I can't graph those. It has to be a real number in order for me to graph it, and I can't graph it. Okay? So there's how we get our zeros and x-intercepts from a polynomial function.